Hi everyone, welcome back to my channel All in One Education. Today we are going to start a new course series which is machine learning. And the problem we will solve in machine learning is the KNN algorithm, which stands for K nearest neighbor algorithm, which is a supervised learning algorithm and a classification algorithm. So what we have here is a data set of 15 rows in the form of points, coordinates and class labels, and what we have to do with it to find the class label of the new data point. The coordinate means the data has two variables x and y. You can be given the data as a set of coordinates or in the form of x and y in the separate columns, so don't worry. So the data point P57 is given and we have to find out its class label using KNN classification algorithm, which predicts after analyzing its neighbors. So basically there are three ways to solve this problem. One through Euclidean distance formula, the second through Manhattan distance, and the last one is cosine similarity. And we are going to use Euclidean distance formula, whose formula is right now in your screens. So this is basically Euclidean distance formula. The first task is to calculate the Euclidean distance of each data point for the new data point, which is 5, 7. For that I need another similar table as this one. So I've already just copied and pasted their table over here, but I've already replaced one column which we have class label. Now it becomes distance from P57 because class label is not necessary right now. Now according to the Euclidean distance formula, x2 minus x1 whole square plus y2 minus y1 whole square and whole under root. Here the issue is not whether you take new data point as x1 y1 or x2 y2, because if they are square the answer will remain equal. I take new data points as x2 y2 and given data point as x1 y1. So let's start calculating the Euclidean distance of each point. I am using Microsoft Excel, so I will use a formula, but you have to show working by putting values in the Euclidean distance formula. So first we have data point 210, so I will put square root in here, which we have x2 minus x1. So my x2 will be new data point, so x2 will be 5 minus x1 will be given data point, which is 2 whole square cap 2 plus y2 will be new data point, so we have new data point 7 minus y1 will be given data point, which is 10 whole square bracket close. So the Euclidean distance of first data point 210 is 4.242. So it's like 6 to 7 digits after decimal, but you guys can take only 3 digits. Up to 3 digits is fine. So we have to calculate all 14 more data points. So for data point 2, square root x2 will be 5 minus now 2 whole square plus 7 minus 6 whole square bracket close enter. So now it's 3.16. Same goes with the other one. Square root x2 5 minus 11 whole square plus 7 minus 11 whole square bracket close 7.21. Square root 5 minus 6 whole square plus 9 minus 7. I mean 7 minus 9. Bracket close. So one bracket is missing. 2.23. Other is square root, another bracket x2 5 minus 6 whole square plus 7 minus 5 whole square bracket close it's same. As you can see, the data point A4, A5 Euclidean distance is completely same, every digit. So the next square root x2 will be 1, x2 will be 5 minus 1 whole square, 7 minus 2 whole square bracket close, 6.40 square root 5 minus 5, 7 minus 10, so I have just forget cap. So it's total 3, exact 3 square root 5, 5 minus 4 whole square plus 7 minus 9 whole square, 2.23 square root x2 5 minus 10 whole square plus 7 minus 12 whole square bracket close, 7.07 square root another bracket 5 minus 7 whole square plus 7 minus 5 whole square bracket close, 2.82 square root 5 minus 9 whole square plus 7 minus 11 whole square bracket close, 5.65 square root 5 minus 4 whole square plus 7 minus 6 whole square bracket close, 1.41 5 minus 3 whole square plus 7 minus 10 whole square, oh I forgot bracket, 3.60 square root 5 minus 3 whole square plus 7 minus 8 whole square bracket close, 2.23 square root bracket 5 minus 6 whole square plus 7 minus 11 whole square bracket close, 4.12. As you guys can see, we have calculated all the distances. So we have to sort the data in ascending order with respect to distances. What does it mean? Means that the data points whose Euclidean distance is less than the other, so we will write it first. So I've already copied another table, it's same as this one, just we need to rearrange the data. So I just erase it because it will going to be shuffle. Let's start sorting. So first data we have is 1.41. So A12 we have shortest Euclidean distance is 1.41. So we'll write A12 4 6 and the value we have is 1.4142135562. And the other, now the next one we have is, we can see this. Now the problem is A4 and A5 had same distance, 2.236067977. So we will take the data point which comes first. As we can see, data point A4 is written before A5, so we will, according to the sequence, we will take A4 first. So A4, and the data point is 6969, and the value is 2.236. So now I will also take only 3 digits because it's too large values. So A5, data points of A5 is 65, and the value is exact same. So what will be the next? So the next will be, see this. This one is also same. Which one was that? A8 49 data point, and the value exact same. Now the next one we have, oh, we got another same value, A14. So A14, data point 3,8, and the value again same. So the next value we have 2.82, A10. So the data 8.810, coordinates we have 8.75, and the value we have is 2.828. Now the next one we have is exact 3, 510, which is A7, 510. The value is exact same. Next is 3.16, this A2, 6 data points, and the value was 3.162. And the next one we have is 3.60, A13, data points 3,10, and the value we have is 3.605. Next we have this 4.12, A15, 6,11, and the value we have is 4.123. Another value if we have in 4, this A1, the coordinates we have of A1 is 2,10, and the value was 4.242. Now next value we have is 5 series, or 5.656, A11, 9, 11, coordinates 5.656. Now next value we have is 6.40, A6, coordinates of A6 is 1, 2. So A6 1, 2, 6.403, 6.403. Now the next is we have 7 series. So 7 we have first 7.071, A9, coordinates we have 10 to 7.071. It's 10, 12. Now the last we have is A3 11 11. A3 11 11 coordinates, and the value we have is 7.211. So after sorting, we have to consider odd values of k, like 3, 5, 7. In most of the questions, you will see that they have solved the question with only one k value, which is like k is equals to 3. But I will recommend you that if your data set is more than 10 rows, so at least take 3 values of k, like 3, 5, 7, to get more accurate result. So let's start with k is equals to 3. What we have to do now? We have to select three data points starting 3 data points from the sorted list and write it over here. But this time we will use their class label instead of distance. But you guys can show distance as well in separate column if you want or have time. So let's start. First we have is A12. So A12, we have A12 coordinate 4, 6, and the value we got is 1.414. Another is 2.236, 2.236, 2.236, and the point A4, A5, A4, A5. What are the data coordinates? 6965, 6, 9, 6, 5. Oh, sorry, I forgot. We didn't have to write distance. So the class labels we have for A12, A4, A5, we have to check the initial table which we got in the question. A12 we have class label C1, A12 C1, A4 and A5. A4 we have C2, A5 we have C1. So C2 and C1, C2, C1. As you can see, we got two class labels C1 and one C2. So the class label predicted for new data point according to k is equals to 3 is C1. But wait, we have two k's left. Now for k5, repeat the step. Now we have to select starting 5 data from the sorted list. Starting 3 will remain same, so I just copy it down here and paste it. A5, 6, 5, C1. Now the next two we have to check sorted list. A8, A14, A8 and A14. What are the data coordinates? 4938, 4938. Now for the class label we have to go to initial table A8 and A14. A8 is C2, A14 is also C2. So both are C2. In K5 we have 3 C2 and 2 C1. So the class label predicted for new data point according to C5 is C2. But let's also check C7. So the starting 5 for C7 will remain same. So I just copy them down here. A14, 3, 8, C2. Now the next two we have to check sorted list. A10 and A7. A10 and A7. What are the data coordinates? 7, 5, 5, 10. 7, 5, 5, 10. So the class label for A10 and A7. A10 is C1, A7 is C2. So C1 and C2. C1 and C2. In K7 we have 4 C2 and 3 C1. So the class label predicted for new data point according to K7 is C2, and K is equals to 5 is also C2. As you can see, if we had taken K1, our answer would have been C1, which turned out to be wrong, because when we further solved the question for K5 and K7, we found out that the answer is C2. That's why I told you to take a value of K more than 1 and check the answer. So the last class label decided for data point P57 will be C2. That's all for today. I hope you have understood this question. I will show you a quick round of the question. Quick review. Uh, so this was our question, which we have points, coordinates, class label. This was a Euclidean distance formula. We calculated each data point Euclidean distance, then we sorted this list, and then considering k value, we find out the class label of new data point. So I hope you have understood this question. See you in the next video. Till then, take care of yourself, subscribe to the channel, and hit the bell icon so that you get a notification of the upcoming video. Bye now.